is Honors Algebra 2 Pre-Calc. This will be our last video in 2.4. So we're going to do some composition of functions, but we're going to do it with word problems. So word problem alert. So you have two coupons for your favorite store. One is $10 off and the other is 25% off. If you can use both on your purchase, in what order should you use them? Right, because here the goal is for you to save money, right? So here's the trick. In the real world, you don't have this kind of choice. Number one, most stores say one coupon per customer per purchase, right? And number two, if you do use two things at once, the computer generally automatically applies them in such an order that you save less money, not more, right? But we're going to pretend that you have the choice to say, here, use this coupon first and then use this coupon, right? Maybe you're purchasing in person at a store that is not using any sort of computer to optimize their sales, and you've decided you want to save as much money as possible. So here's the idea. I'm going to have my two coupons, and I'm going to give each of them a name, right? So I'm going to go ahead and call the $10 off, right? I'm going to say that the $10 off is the coupon f of x, where it's essentially x minus 10, right? Because $10 off, right? You're taking $10 off the price, right? So where x is the price, right? So x is the price, right? The original price that you're being told that your cost is, right? So x is the price. F of x would be x minus 10, right? Because that's $10 off, right? And I'm going to use the 25% off. I'm going to go ahead and call that g of x, and you didn't have to pick f and g. You could have picked something else if there was a good abbreviation for 25, but you could call that like Q for quarter, right? Okay, so g of x. Now the trick is if you're not paying 25%, then you are paying the other 75%. So this is 0.75x. Okay, that's what it would look like if you took 25% off. An easy way to see that this works is just test these out with an easy number. Let's say the item you were going to buy was $100. If you were going to buy a $100 item and you plug in 100 to f of x, f of 100 should be 90 because you were going to buy a $100 item and you took $10 off, and f of 100 is 90. G of x should be $75 because if you were going to buy a $100 item and you're not paying 25%, you are paying the other 75%, which would be $75. So both of these work. So when I ask you the question of which coupon you should use first, this is asking you, do you want f of g of x or g of f of x, right? So essentially, the question I'm actually being asked is, should I do f of g or g of f, right? So let's figure out which both of them are, and then we can see which one gives us a better deal. So let's do f of g. Remember that would be f outside the g function, which means g minus 10. So that's a 0.75x minus 10, right? If I do g of f, right, that's g outside the f function, well, that's going to be 0.75 times f, which is going to be a 0.75 times x minus 10, or a 0.75x minus 7.5. So if you compare these two answers, right, this is one order and this is the other, right? One easy way, if you're having trouble like quantifying, if you're like, I can't tell which of these will be the smaller number, 0.75x is going to be the same amount either way. It's just whether you're taking $7.50 off the price or you're taking $10 off the price. This one's better. If you're having trouble picturing that, pick an easy price. Again, I just go with 100. It's a really safe bet. You can check if you want. Pick an easy x, right? So I can pick an easy x. I'm going to pick x as 100, right? So if I plug in 100 here, I get 75 minus 10, which would mean I'd pay $65, right? If I plug in here, I get 75 minus 7.5, right? Which means I pay $67.50. So this one's better, right? So f of g is better. So what this is telling me is that the first thing I want to do, right? The first thing I want to do is the g function. I want to take off the 75%. So first, or take off the 25%, right? 25% off. Then minus the $10, right? And that actually makes logical sense if you think about it, because if you do the $10 first, then you're taking 75% of a smaller number, right? So you're not getting as big a discount. 25% of 100 is bigger than 25% of 90. That's really what it comes down to. So it's smarter to use, whereas the $10 is the same amount no matter how much the price is, right? $10 off an $11 item is still $10 off. $10 off a $100 item is still $100 or is still $10 off. But the 25% is better to be used when the price is higher because the percentage changes as the number, like the percentage value will change as the number gets smaller. So if you're ever given the choice, you always want to take the percentage off first and then take that flat fee off. Again, in reality stores don't give you a choice. Like in the real world now, computer programming has made it so that the computers, if they do let you use multiple coupons, they optimize which coupon is better. And most of the time they get around it by just telling you can't use multiple coupons. So P6 is literally the same problem, but with 30% and $5 off. So it's gonna essentially be the same result. You're gonna want to take the 30% off while the price is bigger, and then take the $5 off. And that's always the way these work, because if one of the values is a percentage and the other one is a flat rate, you want to do the percentage while the price is higher. But I'm going to let you walk through it anyway. So try P6. I'm going to erase this, and we're going to walk through P6. Yet again, I'm going to write a function for each of these. So I'm going to go ahead and say that the $5 off is f of x equals x minus 5. And I'm going to say that the 30% off is g of x equals 0.7x, right? Because if you're taking 30% off, you're keeping 70%. So f of g would be g minus 5, which is 0.7x minus 5. And g of f would be 0.7 times f, which is a 0.7 times x minus 5, right? So it's a 0.7x minus 3.5, right? So again, same argument. This price is the same as this price. It's better to take $5 off than $3.50. So you want to do this, right? So you want to do the 30% off first while the price is highest, right? And then take off the $5 because that's a flat rate, right? That's a flat fee that you're taking off. Okay, so that's kind of the gist. Anyway, that's the basic idea of composition of functions and operations with functions, and that's 2.4.